Okay, all you mathematicians, let's talk today about special relationships or functions. A special relationship or a function is where each element of the domain is matched with an element of the range. We know our domain are our x values and our ranges are y values. That means that all the domain elements must be different. There are 4 ways to represent a function. One is verbally, that would be like a sentence or an application problem. Numerically, which would be a table. And that would include like point plotting we did earlier where we actually just create a little t-table. That would be numerically a way to represent a function. Graphically, which would be a graph. And algebraically, which is an equation. And you should be able to use these interchangeably, and actually some help you support the other. So a table can help you graph, and a graph can help you write an equation can help you graph, and a sentence can help you come up with an algebraic equation. So they can all be used to support each other. Okay, Bearcats, let's review domain and add to our knowledge some restrictions. You know about domain, but you may not know about the restrictions on domains as we move further along in math. All right, let's talk about domain. Domain are our x values, and so every time you say the word domain, you should think of your x values. These are all the real numbers for which an expression is defined or make the expression true. All the x values are all the independent variables. In equations, when we look at equations, there are a few common domain restrictions, things that we know cannot happen. For example, one of those common restrictions would be you could have no x values that yield a 0 in the denominator of a fraction. So if you have a fraction and you plug in an x value that would create a 0 in your denominator, that can't happen because you would have an undefined slope or an undefined term. So that is a common restriction. The second common restriction would be no x values that yield a negative in a square root. And you know that we can't have a negative under a square root. It's an imaginary term or an undefined term. Zeros are okay though. So in other words, you can take a 0, a square root of a 0, that's 0, but you cannot have a negative number. And that's kind of, sometimes you can get the zeros mixed up with the restriction on a fraction or a rational function. Third is one that you probably have not really thought about, but third is a radius must be positive. So a radius in a circle is a distance, and distance must always be positive. So those are 3 common restrictions of your domain. Make sure you have those in your notes. Pause if you need to. The range, which are our y values, so every time you see the word range, just think of the y values, are the output values created when you put an x value into an equation, you get an output. It's the y values are the dependent variables. We're next going to look at a piecewise defined function, something that you may be a little bit familiar with, but something that we will use a lot here in pre-cal and future math classes. So you want to be very comfortable with it. We're going to use our point plotting and our definitions of domain and range, and also identify any restrictions that we might have. So go ahead and make sure you have this down, and then we'll get ready for this next example. Okay, this is a piecewise defined function. A piecewise function means that the whole all of the parts of the graph make up the function, but there are different parts or different pieces of that function, and each piece has its own restriction. These are your given restrictions. And this is where you always start. These are also, just like our square root, these are really plotted well by using the point plotting method. So we're going to do that. We're going to have one plot or one t-table for our first equation, which is our x squared plus 1, which is a quadratic, which you know is a curve. Okay, so those are all the things you know about x squared plus 1. We're going to go ahead and plot our x and our y values. And then second, we will plot points for our line. X minus 1 is linear. We know it's a line. And then we will be able to graph our function. Okay, our x squared, and that doesn't look very good. If you can read that. Our x squared plus 1 is a quadratic. We did a very good job on that. And we need to start with our restrictions. So notice our restriction is x is less than 0. We still start with 0, but on a graph we'll have an open circle where it's at 0 because it's going to be everything less than 0, but you can't omit 0. You can't start with -1. You have to start with 0. So we're going to plug in 0. So we basically plug in a 0 for the x, square it, we get 0 plus 1 would be 1. Then we're going to pick points that are less than 0. We need several points for a curve to make sure we have a nice curve. So we're going to plug in -1 in for this x. When we do that, we will get 2. And we'll plug in -2. And when we do, we're going to get 5. All right, and we'll plot those points. So I'm going to go ahead and set up my graph here. Again, I'm just, sketching. And not a very good job of it. You might do a better job in your notes. Also, in your notes, I have some peel off and stick graphs. If you want to use those, just ask me about it. All right, so 0, 1. So for this, since it is not equal to 0, at 0 we have a point at 1, but we're going to have an open circle. At -1, we're going to have a point at 2. And at -2, we're going to have a point at 5. So 1, 2, 3, 4, 5. So way up here. And we know it's a curve because it's quadratic, so let's make sure we don't draw it like a straight line. So we're going to start here, and it's going to curve upward. And that is that piece of the function, and the restriction is noted by the open circle at 0. All right, let's go ahead and plot some points for our line. Again, because we're given a restriction, x is greater than or equal to 0, we're going to go ahead and start with 0. We put a 0 in, we're going to get -1. Since it's got to be greater than that, we'll put 1 and we'll get 0, and we'll go ahead and do one more and we'll put 2 and get 1. Okay, those are 3 points on our line. Because it can be equal at 0, we will have a solid dot at 0, -1. So at 0, -1, we'll have a solid dot. At 1, 0, we have a solid dot. And at 2, 1, we'll have a solid dot. And our line will go off and look something like this. And that is the other piece of our piecewise function. All right, looking at the graph, let's identify our domain and our range. All right, so domain. And I'm going to use interval notation. If that is something that you are not comfortable with, then you need to task me or your peers about it in class. All right, so looking at our graph, we come from the left side, -infinity, so our domain values, this graph would continue to go off, so -infinity would be covered all the way till we get to 0, and we have an open circle, but down here we have a closed circle, so that makes up for it. So there are x values at, we do have the x value 0, even though it's open here, and we would continue and we go off to positive infinity this direction. So our domain would really be negative to positive infinity. Now let's look at our range. Our range would be the lowest part of our graph. The lowest y value on our graph would be down here at -1. And we would be equal at -1. And then we would go up and we would have y values here and here and here and on one of the graphs forever and ever and ever, so to positive infinity. If that is sketchy for you or you need some questions, ask me in class. Make sure you have these notes, and now we're going to move on to the difference quotient. All right, let's talk a little bit about the difference quotient. This, along with limits that we will study later, are two of the most used concepts in calculus. The difference quotient, which I've listed here, part of it anyway. The difference quotient, which I've listed here, is a fraction, so that's where you get the word quotient, and it also takes the difference at the top. That's where you get difference, so there is your name, difference quotient. The difference quotient is like our next step in our journey of slopes. It's not going to give you the slope of a line, but it's going to give you the slope of a point on a curve. In calculus, this will be called a derivative. Feel free to Google this information, explore a little bit more. If you just plug in difference quotient into Google, it gives you a lot of information, and there's some really things on Cool Math and just the first few websites that come up after you type in what is a difference quotient and how it is used. So what we're going to focus on today are just the mechanics of using this difference quotient so that we can have all the skill sets that you need to move on to calculus. Okay, first let's remember our functions. F of x is x squared minus 4x plus 7. But we're also, which is right here, which we're going to just substitute that in. But we also want f of x plus h for this. And that would be, we're going to substitute x plus h, this chunk, in for this x and this x. So in parentheses you would have x plus h squared minus 4 times x plus h plus 7. Okay, now with that little review, let's go ahead and plug into our difference quotient. So for f of x plus h, we would have, we just did that, x plus h squared minus 4 times x plus h plus 7. And now we want to subtract. And when we subtract things, we're going to go ahead and put them in parentheses. We're going to subtract f of x. Well, f of x is this entire thing. So we're going to subtract x squared minus 4x plus 7. And we're going to divide it all by h. If we go through this process correctly, one of our h's will factor out and we'll simplify our equation down. So we're going to do that with some foiling and different things. If you get hung up in this part, then you need to see me. Remember, there is a shortcut when you FOIL a binomial, when you square a binomial. If you don't know this shortcut, you need to ask me in class. The shortcut is to square the first term, which would be x squared. Multiply the two terms together, the x and the h, and then multiply that by 2. So x times h times 2 would be a positive 2xh. And then square the second term, which is h squared. That's the shortcut rather than actually foiling. We've got to distribute our negative 4, so minus 4x and minus 4h. And then we still have the plus 7. And then we need to distribute this negative all the way through. So minus x squared plus 4x and minus 7. And that will all be over h. If you do this correctly, you'll have a lot of cancellations. Notice we have a positive x squared cancel with a negative x squared. We have a negative 4x cancel with a positive 4x. We have a positive 7 cancel with a negative 7. So if you do that correctly, this is what you will get. You will be left with 2xh plus h squared minus 4h all over h. Notice in our numerator, each term has an h, and we're going to factor that out. So we're going to take the h out, and we would have a. So we're going to take one of these h's. They all have in common, so a greatest common factor of h. And inside we would have 2x plus h minus 4 all over h. And that h will cancel with our denominator, and therefore our difference quotient will yield a derivative, which you will learn about later, 2x plus h minus 4, with the restriction, of course, that h cannot equal 0. And that's the restriction that we were given in the beginning. And that would be our difference quotient. All right, go Bearcats. Good luck on your quiz tomorrow. Make sure you have these notes.